So, in order to understand the motion of an object, you need to identify the combination of all forces acting on it. So far, we've sort of simplified situations and talked about just one force acting on an object, causing it to move. But that's not the case all the time. There's very frequently multiple forces acting on an object at once, and we call the combination of all those forces together the net force on an object. When both forces, or all, 7 forces or whatever, act in the same direction on an object, then we're going to add them up together. So that would look something like this. When you have a force, okay, let's say like a 200 Newton force, and maybe just a 100 Newton force. Okay. So then we're going to add those up together. 200 plus 100 is going to yield us a 300 Newton force to the right. Okay, so it's as if one person was pushing on this box with a force of 300 newtons to the right, even though there are 2 forces pushing on it, in fact. Okay, we sum them together. Bless you.
God bless.
So, I want you to notice that because all of these forces are pushing in the same direction, we've made them positive. That's because we've chosen a reference direction. A reference direction is just us saying, if you're moving in this direction, your movement's going to be considered a positive force. If you're moving in the opposite direction, we would then consider your force a negative force. Okay? In this example, our reference direction is to the right, and because of that, both forces on this box are indicated as being positive forces. Okay? But the forces aren't always going to be in the same direction. Okay? When forces are in opposite directions, we're still adding them, but because one of those forces is going to be going opposite to what we say the reference direction is, then we're going to indicate that force as being a negative force. So it's as though we are subtracting them, because if you add a negative and a positive number, it's like doing subtraction. So that might look something like this. If you have a 200 Newton force going in this direction, and then you have a 100 Newton force going in the opposite direction, then that force is going to be considered negative. Okay, so yes, so you'd have 200 minus 100 equaling out to 100 Newton force. So since there are 2 forces acting on this, it's as though there's just one force acting on it, causing it to go in the right direction. Okay, you guys saw this when you were playing tug of war, right? The object moved in the direction of the stronger force.
Is that one of those heavy weights in it?
So, when multiple forces are acting on an object, the result can be one of 2 things. The first one is that we can say that those forces are balanced. So think about an object where a force is acting in one direction and an equal force is acting in the opposite direction. Then we wind up having equal forces in opposite directions makes the forces balanced, which equals a net force of 0. Okay? When objects are experiencing a net force of 0, they are not in motion. Okay, so this box would not be moving because the 2 people pulling on it are pulling with the same strength in opposite directions, so the forces on the box balance and it doesn't move. It has a net force of 0. The other option is that our forces can be considered unbalanced. Okay, so in this example, let's say we have a force of 100 newtons pulling in this direction and then a push force of 100 newtons in the same direction. Okay? Then we're going to wind up with 100 plus 100, and you're going to wind up with a 200 Newton force. So there is going to be motion here. This is unbalanced. Just because forces are acting in opposite directions doesn't necessarily always mean that they're balanced, though. Like in the first example, when we had the 200 force pulling in one direction and the 100 force pulling in the other direction, opposite forces, but because the 200 Newton force is stronger, it's unbalanced still, and we still wind up with motion. Okay? Now that we understand what it means to be balanced and unbalanced, we can talk about Newton's first law of motion. Okay? An object that's in motion will stay in the same motion unless it's acted on by an unbalanced force. So here's what that means. It means that if the object is already in motion, it's going to stay in motion, and it's going to stay in motion at the same velocity. Okay? The example I give for this is objects that fall reach a terminal velocity when gravity and air resistance are balanced. So as you're falling, as you begin your fall, you're obviously going to speed up, right? As gravity pulls more on you. But when you reach the point in your fall where the force of gravity is balanced by the force of air resistance, then your velocity stops changing. You stay in motion because you're in motion, but your velocity doesn't change because the forces working on you are now balanced. Okay? Objects that are already at rest are going to stay at rest. If you have a ball sitting on a level piece of ground, it's not going to move unless a force acts on it. If the ground wasn't level, then gravity could act on it and it might move. But as long as there are no unbalanced forces acting on it, the ball will stay. As long as the force of gravity and the force pushing up on it from the ground remain balanced, that object is not going to just suddenly start moving. This is the property of matter known as inertia, the tendency of an object to resist changes in its motion. When you did the experiment in the lab where you stacked up the wooden blocks and you put note cards between them, and then you tried to remove those note cards without moving the blocks, and then you repeated the same experiment with styrofoam cups, what you observed is that one of those objects had more inertia than the other. Which one was it? The wooden blocks, yes. Wooden blocks have more mass, and as a result of having more mass, they have a greater inertia, which means it requires more force to move them from being at rest to being in motion. The styrofoam cups have a lot less mass, so their inertia is much less, meaning it doesn't require as much force to set them into motion. But it still requires an unbalanced force to overcome that inertia. So the cups didn't just start moving for no reason. They only moved when you tried to remove the note card. When forces on an object are not balanced, as we just discussed, that is when we see changes in motion happening. Okay, so cars slow down when friction from their brakes overcomes the force by the drive shaft. So when that becomes an unbalanced force. As long as the friction from the brakes or from the road is equal to the force exerted by the engine on the drive shaft, then the car doesn't slow down. It continues at a constant velocity. But as soon as that friction increases to a point where the force becomes unbalanced, that car begins to slow down. A book that's sitting on a table isn't going to move from being at rest until you apply an unbalanced force to it. Okay? On Earth, objects largely stop moving because of friction. So in the example of the car, notice that I said friction from the brakes or from the road surface, because we all know if you don't have your car on cruise control and you take your foot off the accelerator, you're going to start slowing down, right? That's because there's lots of friction involved there. There's friction between the wheels and the surface of the road you're traveling on. There's friction between all moving parts inside the motor, and engine and the drive shaft of your vehicle. All of those moving parts have friction. We try to minimize it by adding oil and grease and things, but we can't 100% do away with it, which is why if you step off that accelerator, it's always going to start slowing down because that friction is going to unbalance those forces and cause a change in that motion. Okay? All right, this is where we're stopping for today.
Oh, man.